Good morning, class. So in the last lecture we have seen angiotensin 2 receptor blocker. So the drug which binds to the angiotensin 2 receptor and inhibit the activity of angiotensin 2. Such drugs it called as angiotensin 2 receptor blockers. So when angiotensin 1 converts into the angiotensin 2, what happens? This angiotensin 2 it binds to the receptor, and after binding to the receptor it performs its activity. But these drugs are responsible to bind this receptor and block the receptor, so that the angiotensin 2 it cannot bind to the receptor, and when it will not bind to the receptor, it will not show the further activity which is responsible to increase the blood pressure. So in this way, these blockers they bind to the receptor, they block the activity of angiotensin 2 and responsible to act as an antihypertensive agent. So they reduces the blood pressure, they reduces the resistance, blood flow, and they normalize the pressure. जे वाढलेलं प्रेशर आहे ते कमी करायचं काम करतात. So these receptors, there are two receptors. One is AT1 receptor, second one is AT2 receptor, that is angiotensin 2 receptor type 1. This is angiotensin 2 receptor type 2. Okay, so out of which the angiotensin receptor type 1 it is mainly responsible to increase the blood pressure. They are also responsible for the vasoconstriction. Okay, so they are generally present in the smooth muscle, they are responsible for the constriction. So if we are giving the blockers, they are generally act on AT1. So blockers which are developed such that they are responsible to bind to the angiotensin 2 receptor type 1 and block the activity of angiotensin 2 after binding to this AT1. So we are not related with the AT2. Our blockers they are mainly related with the AT1, that is the angiotensin 2 receptor type 1. Now what are the functions of this angiotensin receptor? Okay, so this angiotensin receptor 1 they are generally found in the smooth muscle cell, then they are found in the adrenal glands, as well as they are found in the nerve synapses. So when the drug binds to this receptor, it blocks the activity. That means in the smooth muscle they are responsible for the vasodilatation. Regarding the adrenal gland, it reduces the production of or the secretion of vasopressin. They are also responsible for the reducing the production as well as the secretion of aldosterone, which is responsible to maintain the sodium water level. They reabsorb the sodium and water. So combined effect of all these, that is the vasodilatation, reduce the secretion of vasopressin, they reduce the production and secretion of aldosterone. Combined effect of that, it will reduces the blood pressure. In this way, they act as the antihypertensive agent. So in this way, this blocker works. Okay, so AT1 receptor कुठे कुठे असतो? स्मूथ मसल मध्ये असतो, ग्लँड मध्ये, ॲड्रेनल ग्लँड मध्ये असतात, as well as the adrenergic synapse, जे नर्व सिनॅप्सिस आहेत त्याच्यामध्ये ते प्रेझेंट असतात. तर स्मूथ मसल मध्ये ते काय करतात? they cause the contraction. So when we are giving the drug, instead of contraction, they shows the effect, that is the vasodilatation. In the adrenal gland, they are responsible to reduce the secretion of different hormones. So they are responsible to reduce the secretion of vasopressin, as well as in case of aldosterone, the production and the secretion of aldosterone it also decreases. So due to the decrease in this aldosterone, vasopressin as well as the vasodilatation, ultimately what it comes, it results into the reduction of or reducing the blood pressure. So in this way, these receptor blockers they act as the antihypertensive agents by blocking the angiotensin 2 receptor type 1. Then we have seen how the development of angiotensin 2 receptor blocker takes place. So the initial step was the angiotensin 2 receptor. Okay, so when there is a complementary functional groups or the complementary groups which are present in the receptor as well as in the drug, then only they can bind to the receptor instead of substrate. So इथं substrate कुठला आहे? Substrate is the angiotensin 2. Receptor कुठला आहे? Angiotensin 2 receptor. बरोबर आहे? So the drug should have the complementary functional groups or the complementary groups which relates to the angiotensin 2 receptor. Okay, then only they can bind to the receptor and they will block the receptor. So the development of these angiotensin 2 receptor blockers, they started by considering this effect. Which effect? When the angiotensin 2 binds to the angiotensin 2 receptor. But if the drug having the similar kind of structure with the angiotensin 2 or similar complementary functional groups or the groups which are present in the receptor, so that they can bind to the receptor, on the basis of that the development of angiotensin 2 receptor blockers start. So in the early 1970s they focus mainly the drugs which having the peptide linkage in their structure. Okay, so what they have considered, if peptide linkage will be there or the peptide bond will be there which is resembles with the natural agonist, so if the peptide will be there they will show the better activity. So considering that one, the prototype compound was introduced, and this prototype compound was saralacin. This saralacin is a octapeptide, so 8 peptide bonds they present in the structure. Okay, so that was the first drug. After considering that the peptide linkage must be present in the structure, but there is a drawback or the disadvantage if the peptide linkage is present. What is the disadvantage? It lacks the oral bioavailability, and it also shows the some kind of agonist effect. Agonist effect some kind means it shows the partial agonist activity. So these are the two disadvantages with respect to the saralacin. One disadvantage is what? Partial agonist activity. Second one, lack of oral bioavailability. So they found that the peptide linkage which is present, it is responsible to show this kind of disadvantages. So what they do? They change the peptide linkage, and they found that due to the peptide based antagonist they produce such problems, so we have to change the peptide linkage. So next drug was approved, that is the losartan, which is the non-peptide blocker. त्याच्यामध्ये पेप्टाइड लिंकेज तुम्हाला मिळणार नाही. Okay, so this development of losartan, then valsartan. Okay, so different drugs are there which are the angiotensin 2 receptor blockers, telmisartan. Okay, so these drugs comes how? By considering the fact that if non-peptide linkage is present, they will show more bioavailability as well as the better oral absorption. Okay, by considering these, they changes from peptide to the non-peptide structure. So in this way the development of losartan takes place from saralacin. Now how the development takes place? So this development of losartan started from saralacin, but saralacin is the peptide. Then after considering the disadvantage of peptide linkage, they have formed a non-peptide. Which non-peptide? S3808 compound. So this S3808 compound is a non-peptide, but what they found, it has the weak activity. So weak antagonist activity. जी activity ही saralacin एवढी चांगली नव्हती. It was the weak activity, but the major advantage was that it was not showing any kind of side effects. Okay, saralacin चे disadvantage कुठले? Bioavailability, oral absorption. त्यानंतर ते कशामुळे येतात? Disadvantage due to the peptide bond. So they have changed peptide to the non-peptide. Non-peptide मधलं पहिलं ड्रग कुठलं? S3808. This is the non-peptide. So non-peptide चा advantage काय? Very less side effects or agonist activity काहीही दाखवत नव्हतं. So it was not the partial agonist. But disadvantage काय? Weak activity. That was the disadvantages. Okay, then they found that there are some structures which is present in the S3808 which was correlating with the angiotensin 2. Okay, so this is the angiotensin 2. So they have found that 1, 2, 3, 4 butyl ring. Here is also butyl ring is butyl chain is present. Here imidazole ring is present. Here is also imidazole. Here carboxylate. Here is also carboxylate. So these are the three. That is the carboxylate, imidazole ring, and N-butyl group. So these are the three parts which are majorly present in the S3808, which was complementary or which was showing the similar kind of structure which is present in the angiotensin 2. So saralasin पासून S3808 आले. आता त्यांनी काय केलं, S380 weak antagonist आहे. Okay, but they having the similar kind of structure which is present in the angiotensin 2. So they started to develop the drug which having the similar kind of structure like S3808. And from that they found a drug that is the losartan. So after certain development they formed the drug losartan. That was the first marketed drug which was given as an angiotensin receptor blocker. So from this drug to this drug, so they having the IC50 value 15 and this having the only 0.090. So it having the greater activity as compared to the S3808. So in this way the development of structure takes place. Okay, so that is about the development of angiotensin 2 receptor blockers. लक्षात काय राहायचं, फर्स्ट पॉइंट agonist किंवा जे similar kind of structure they having the peptide linkage, so they develop a drug which having the peptide bonds. So they first form saralasin, पण पेप्टाइड बॉन्ड असल्यामुळे दोन डिसएडव्हांटेज मिळाले, एक बायोएबिलिटी, सेकंड वन ओरल absorption. So they come to know that these two disadvantages is due to the peptide bond, as well as they were showing the, it was showing the partial agonist effect. Okay, so हे कशामुळे होत होतं, due to the peptide. So they move from peptide to the non-peptide, and first was S3808. So S380 चा advantage काय, partial agonist नव्हतं, कुठली agonist activity दाखवत नव्हती, but it was showing the weak activity, that is the weak antagonist. आणि advantage दुसरा काय अजून, they having the similar kind of structure with the angiotensin 2, that is the carboxylate, imidazole ring and the N-butyl chain. So from that, by taking this consideration, they form a drug that is the losartan, which was non-peptide angiotensin 2 receptor blocker, which was approved in 1995. So in this way, from saralasin to the S3808, from S3808 to the losartan, the development takes place. Okay, so that is the part regarding the development of angiotensin receptor blocker. So these are other some drugs, that is the valsartan, olmesartan. So this is the structure of valsartan, this is the structure of olmesartan, this is the azilasartan, this is the telmisartan. So these are some drugs which are approved as a angiotensin receptor blocker. You can say angiotensin 2 receptor blockers. Now we move to the next part. After finishing the part that is the angiotensin receptor blockers, we are moving to the next part, that is the combination of drug, that is the valsartan plus sacubitril. So why this combination is given as an antihypertensive agent, okay, that we will see. So sacubitril valsartan, it is generally sold under the brand name that is called as Entresto, and it is the fixed dose combination. They are generally given when there is a heart failure or cardiac heart failure is there. Okay, so in this combination there are two drugs, sacubitril and valsartan. So what is valsartan? It is the angiotensin receptor blocker, that is the angiotensin receptor 2 blocker. And second drug, that is the sacubitril, it is the neprilysin inhibitor. What is that? It is the neprilysin inhibitor. So this neprilysin inhibitor is responsible to, sacubitril is responsible to inhibit the neprilysin. So what was the activity of neprilysin? So neprilysin is present in our body, and what is the role of neprilysin enzyme? So this neprilysin, it is responsible to degrade the vasodilators. आपल्या बॉडी मध्ये जे vasodilators आहेत त्याचं डिग्रेडेड करायचं काम कोण करतं? दिस neprilysin. So adrenomedular, second one bradykinin, and some peptide containing compounds. So ह्या compounds हे काय करतात? डिग्रेड करतात. कोण? neprilysin. So when they degrade this compound, so it is unable to dilate the vessels. But when neprilysin is inhibitor, then there is no degradation of these compounds, that is the peptides असतील, bradykinin असेल, adrenomedullary असेल. So due to this no degradation, their concentration increases and they are responsible to cause the vasodilation. So neprilysinचा रोल काय? डिग्रेड करणे. कुणाला डिग्रेड करतात? जे कंपाऊंड वॅसोडायलेट करतात किंवा वॅसोडायलेशन करणारे जे कंपाऊंड आहे त्यांना डिग्रेड करायचं काम करतात. आता त्यांना जर डिग्रेडेड केलं तर काय होणार आहे? त्यांचं कॉन्सन्ट्रेशन कमी होणार आहे, वॅसोडायलेटेशन होणार नाही. सो महत्वाचा कुठला त्यातला? ब्रॅडिकायनिन आहे, ॲड्रेनोमेडुलर आहे, सम पेप्टाइड कंपाऊंड्स आहेत, वॅसो ऍक्टिव्ह पेप्टाइड कंपाऊंड्स. ओके, सो या तिघांना डिग्रेड करतात, त्यामुळे तिघांचं कॉन्सन्ट्रेशन डिक्रीज होतं. आणि तिघांचं जर कॉन्सन्ट्रेशन डिक्रीज झालं तर वॅसोडायलेटेशन कमी प्रमाणात होतं किंवा वॅसोडायलेटेशन होत नाही. आणि हे सगळं कोण करतं? नेप्रिलायसिन. सो आपण काय करायचं? नेप्रिलायसिन इनिबिटर द्यायचं, विच कॅन इनिबिट द नेप्रिलायसिन. सो देर इज नो अवेबिलिटी ऑफ नेप्रिलायसिन. And if neprilysin is not there, what happens? There is a no degradation of these compounds which are responsible for the vasodilation. आणि त्या तिघांचं जर डिग्रेडेशन झालं नाही, त्याचं कॉन्सन्ट्रेशन आहे तसं राहणार आहे, त्यांचं कॉन्सन्ट्रेशन कमी होणार नाही. कॉन्सन्ट्रेशन जर कमी झालं नाही, they will cause the dilatation. So in this way, this neprilysin inhibitor works. So drug sacubitril is one of the neprilysin inhibitor. Okay, so valsartan, already we have studied, it is the angiotensin receptor blockers. It blocks the angiotensin receptor type 1. This receptor is generally found in vascular smooth muscles, some cells of adrenal gland which is responsible for the aldosterone secretion. So when we are giving the valsartan, they block these receptor, hence it causes the dilatation as well as the reduces the volume, blood volume. So aldosterone secretion होत नाही, वॅसोप्रेसिनचं सिक्रेशन किंवा प्रोडक्शन होत नाही, ऑटोमॅटिकली ब्लड व्हॉल्यूम कमी होतं, ब्लड प्रेशर आहे ते नॉर्मल होतं. सो दॅट इज द valsartan. In the combination, the second drug is the sacubitril. Sacubitril is actually a prodrug. So when this prodrug is given, it enters in our body, it undergo the activation by the enzyme esterase. And that activated enzyme is called as sacubitrillate. लक्षात ठेवा, sacubitril is the prodrug. Sacubitrillate is an active drug. So when it enters in our body, it undergo the hydrolysis or the deethylation via the esterase. And when this reaction takes place, when this metabolism takes place, we are getting the active drug, that is the sacubitrillate. This sacubitrillate is responsible to inhibit the enzyme neprilysin. आता neprilysinचा आपण ऍक्टिव्हिटी बघितलेला आहे. नेप्रिलायसिन इज अ नॅचरल एंडोपेप्टिडेज. सो नावातच आहे पेप्टिडेज, म्हणजे पेप्टाइड लिंकेज ब्रेक करणार. सो नेप्रिलायसिन इज अ न्यूट्रल एंडोपेप्टिडेज. That means they can break the peptides. So these are responsible to degrade vasoactive peptides such as natriuretic peptides, bradykinin as well as the adrenomedullin. The sacubitril increases the level of these peptides and which are responsible to increase the or the causes the blood vessel dilatation. लक्षात आलं? नेप्रिलायसिनचं काय आलं? नेप्रिलायसिन काय करतं? जे कंपाऊंड वॅसोडायलेशन करतात त्याचं डिग्रेडेशन करतात. सो आपण नेप्रिलायसिन ब्रेक केलं तर काय होणार? की नेप्रिलायसिन इनिबिट केलं तर काय होणार? हे जे डिग्रेडेशन होणार आहे ह्या कंपाऊंडचं, नायट्रियुरेटिक पेप्टाइड्स, ब्रॅडिकायनिन, ॲड्रेनोमेडुलिन, त्याचं डिग्रेडेशन होणार नाही, त्यांचं कॉन्सन्ट्रेशन आहे तसं राहणार. दे विल कॉज द वॅसो डायलेटेशन. सो इन दिस वे the combination, that is the valsartan plus sacubitril, works. So valsartan is the angiotensin 2 receptor type 1 blocker and the sacubitril is a prodrug. It is converted into the active drug, that is the sacubitrillate, and this sacubitrillate is responsible to inhibit the enzyme neprilysin. So this is the structure of sacubitrillate and sacubitrillate. So here you can find out esterase there. Okay, so hydrolysis by the enzyme esterase, we are getting the acidic structure which is the actually active drug, or which drug which causes the inhibition of neprilysin. lysine. So that is the conversion of inactive drug sacubitril to the active drug, that is the sacubitrylate. Okay, so this is about the combination of valsartan plus sacubitril. So after seeing the combination of valsartan and sacubitril, we are moving to the next part, that is the next class of drugs which act on renin angiotensin aldosterone system, and that is calcium channel blocker. Calcium channel blocker. So already we have seen the calcium channel blocker in the different chapter or the sub chapter which comes under this drugs acting on the cardiovascular system. So in that calcium channel blockers, the main calcium channel blocker or the main class of calcium channel blocker, that is the dihydropyridine. Okay, so this is the structure of dihydropyridine which act as calcium channel blocker. So there are different types of calcium channel blockers, out of which the one type of the calcium channel blocker is the dihydropyridine as the calcium channel blocker. So here you can check the structure. This is the pyridine, and at the pyridine one phenyl ring is attached or one benzene ring is there. Okay, so that is the general structure of calcium channel blocker. You can see these two groups, 3 at 5th position. Again these two groups, methyl group at the 2 and 6th position. So this is the important part in the exam. Most of the times for the 3 marks they are asking, give the structural activity relationship of the dihydropyridine derivatives, comes under the class, that is the calcium channel blocker. So for that, this is the lead molecule. You can see this is the general structure of dihydropyridine. So number start from this nitrogen. So you can start either from this 2 3 or either from this from 2 3. So if we start 1, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So you can start either from this way or you can start either from this way. You can start from any other numbering. Okay, if you start anyway, at the 4th position there is the presence of a phenyl ring. Okay, and the phenyl ring at the 2nd dash and at the 3rd dash position there are chances of having the some groups, which groups are responsible to increase the activity. So in this way the general structure of dihydropyridine is present. Okay, so we will start the SAR of dihydropyridine. The first one, the substituted phenyl ring at the 4th position, it is responsible for the optimum activity. So if we reduces this ring, ही जी ring आहे वरची, ही ring जर आपण काढली, it will reduces the activity. So this ring must be present for the optimum activity. So at the 4th position there is a presence of phenyl ring which is responsible for the optimum activity. If we are replacing this phenyl ring by any heteroatomic ring like pyridine असेल, pyrrole असेल, like this, if this ring, if we are replacing with any other ring, then it will shows the toxicity or it will increase the toxicity. So there must be presence of this phenyl ring at 4th position instead of any heteroaromatic ring. Or if instead of this ring structure, if we are giving the plain chain structures like alkyl, cycloalkyl, it will decreases the activity. So there must be presence of phenyl ring at 4th position for the better activity. If it is heteroaromatic, it will having the toxicity. If it will having the non-aromatic straight chain or the cycloalkene like this compound, it will reduces the activity. So for the optimum activity, there must be presence of phenyl ring at the 4th position. Then in case of phenyl ring, the substitution is important for the size and positions. The compound with ortho or meta substitution having the optimum activity, whereas those which having the unsubstituted or para substitution, they will decreases the activity. Now this is the phenyl ring. Okay, हे जे आलेलं आहे ते आपल्या डायहायड्रोपायरिडिन कडून आलेलं आहे. ओके, सो दिस इज द सेकंड डॅश, दिस इज द 3 डॅश. सो सेकंड डॅश म्हणजे ऑर्थो आला, 3 डॅश म्हणजे मेटा आला, हा आला पॅरा. बरोबर आहे. जर सबस्टिट्यूशन हे पॅरा पोझिशन वर असेल तर ऍक्टिव्हिटी ही डिक्रीज होते. सो देअर मस्ट बी सबस्टिट्यूशन इन ऑर्थो पोझिशन और मेटा पोझिशन, दॅट इज द 2 डॅश or 3 dash. It should not be at 4 dash position, or it should not be at the para position. If para position, if there is a substitution, it will decrease the activity. Next part regarding this substitution, if the compounds having electron withdrawing group like halogen, if electron withdrawing groups are present, the compound is active. But if electron donating groups are present like CH3, the compound shows good activity. Okay, so electron withdrawing असेल like halogen तरी सुद्धा activity दाखवतं किंवा नायट्रो ग्रुप असेल. But instead of that, if electron donating groups are present, it will show the good activity. So ऑर्थोमेटा पोझिशनला सबस्टिट्यूशन पाहिजे आणि ते इलेक्ट्रॉन विड्रॉइंग असेल किंवा इलेक्ट्रॉन डोनेटिंग असेल. बट ॲट द पॅरा पोझिशन देयर शुड बी नॉट any substitution, otherwise it will decreases the activity. Okay, so the compounds with orthometa substitution, it provides sufficient effect so that the conformation of the 1,4 dihydropyridine is maintained such a way that it should be perpendicular. ही जी बेन्झीन किंवा फिनाइल रिंग आहे ही खालची जी 1,4 डायहायड्रोपायरिडिन रिंग आहे त्याला परपेंडिक्युलर असली पाहिजे. सो सफिशियंट सबस्टिट्यूशन करा, बट दॅट शुड मेंटेन द प्लेन, इट शुड मेंटेन द कन्फर्मेशन, इट शुड नॉट चेंज द कन्फर्मेशन. आणि कन्फर्मेशन कसं आहे, फिनाइल रिंग इज परपेंडिक्युलर टू द बिलो 1,4 डायहायड्रोपायरिडिन रिंग. सो दॅट इज द सेकंड पार्ट. ओके, सो आपण फिनाइल जे सबस्टिट्यूशन आहे त्याचे 2 पॉईंट बघितले. पहिला पॉईंट, फिनाइल सबस्टिट्यूशन असलं पाहिजे, त्याच्या जागी जर अल्किल चेन असेल, सायक्लोअल्किल असेल तर ऍक्टिव्हिटी कमी होणार. दुसरे हेट्रो एरोमॅटिक रिंग असेल तर टॉक्झिसिटी वाढणार. दुसरी गोष्ट, इन केस ऑफ फिनाइल सबस्टिट्यूशन सेकंड डॅश किंवा थर्ड डॅश पोझिशनला, म्हणजे ऑर्थो किंवा मेटा पोझिशनलाच सबस्टिट्यूशन असलं पाहिजे. इफ इट इज प्रेझेंट ॲट द पॅरा पोझिशन, व्हॉट हॅपन्स, इट्स ऍक्टिव्हिटी डिक्रीजेस. देन ऑर्थो आणि मेटा मधले जे सबस्टिट्यूशन आहेत, इलेक्ट्रॉन विड्रॉइंग पण असतील किंवा इलेक्ट्रॉन डोनेटिंग. जर इलेक्ट्रॉन डोनेटिंग ग्रुप असतील, इट विल शो दी बेटर ऍक्टिव्हिटी और इट शो दी गुड ऍक्टिव्हिटी. आणि ते सबस्टिट्यूशन असे असावेत जेणेकरून कन्फर्मेशन जे आहे ते कन्फर्मेशन चेंज होणार नाही. कन्फर्मेशन कसं आहे, फिनाइल रिंग इज द परपेंडिक्युलर टू द plane of 1,4 dihydropyridine. So these are the points which comes under the SAR part regarding these 4 phenyl substitution. Next part, third point, that is the 1,4 dihydropyridine ring is essential for the activity. If the substitution on N1, so N1 ला इथं हायड्रोजन आहे, so हायड्रोजन काढून दुसऱ्या एखादं सबस्टिट्यूशन केलं, or oxidized piperidine ring or reduced pyridine ring, it will decreases the activity. So सगळे दोन्ही सुद्धा डबल बॉन्ड काढले किंवा एक कुठाचा डबल बॉन्ड काढला किंवा हायड्रोजन काढून तिथं CH3 किंवा एखादं सबस्टिट्यूशन केलं, सगळ्यामुळे ऍक्टिव्हिटी ही डिक्रीज होते. दॅट्स वाय 1,4 dihydropyridine is essential for the activity. If it is removed or reduced or hydrogen is replaced by any other group, it will decrease the activity. Next part, you will observe that at 5th position and 3rd position, COO-CH3 group, that is the ester linkage or ester groups are present. Ester group 3 and 5, if they are unequal, जर दोन्ही ग्रुप हे वेगवेगळे असतील, it produces the chiral center at 4th position. And C3 carbonyl is syn periplanar, whereas C5 carbonyl is anti periplanar. and other electron withdrawing groups at this position, it will decreases the activity. So there must be presence of COOCH3. COOCH3 सोडून कुठलेही सबस्टिट्यूशन करू शकत नाही. आता चेक करा एकदा. 1 minute. हा 4 नंबरचा कार्बन आहे, ह्याला एक हायड्रोजन आहे. इथं आहे COOCH3, इथं आहे COOCH3, बरोबर आहे. त्यापैकी जो 3 नंबरचा आहे तो सिन पेरिप्लेनार आहे आणि 5 पोझिशनचा आहे तो अँटी पेरिप्लेनार. एक मार्काला तरी कंपल्सरी क्वेश्चन याच्यावर असतो. सो दॅट इज द stereochemistry of third and fifth ester. So third position ester, that is the sim periplanar. The ester which is present at the fifth position, that is the anti-periplanar. Okay, so for the 1 mark there is a compulsory question on this. Give the stereochemistry of ester linkage or the ester group which is present at the third and fifth position. So at the third position which is present, it is the C periplanar, and at the fifth position which is present, that carbonyl group is the anti-periplanar. Okay, if both groups are same, there is no problem. But suppose one group is ester, another group is another group, it may be C2H5. Now this carbon having one hydrogen at this position, phenyl ring, this is COOC2H5, this is COOCH3. At that case, the carbon becomes chiral center, so it will having the different stereochemistry. So at that position, the third position is the sim periplanar, and at the fifth position the carbonyl group which is the anti-periplanar. And if these groups are replaced by any other electron withdrawing group like nitro group, like halogen group, it will decreases the activity. And you can observe at the next part, at the second and at the sixth position, there is a must presence of methyl group which will shows the optimum activity. So this is about the SAR for 1,4 dihydropyridine derivative which act as the calcium channel blockers. First point, fourth position ला फिनाइल रिंग असली पाहिजे. फिनाइल रिंग मध्ये पॅरा पोझिशन ला सबस्टिट्यूशन असता कामा नये. Substitution must be ortho and meta position. It may be electron withdrawing or it may be the electron donating group, but the group must be such that it should not change the conformation of the 1,4 dihydropyridine. Okay, conformation कसा आहे, it is perpendicular to the 1,4 dihydropyridine. The second one, regarding the ring, the 1,4 dihydropyridine ring is must for the activity. If it is reduced or if the hydrogen is replaced with any other group, it will decreases the activity. Then the ester groups which are present, if they are different, the drug becomes chiral center. At that time, the C3 having the zinc periplanar, C5 having the anti-periplanar structure. Other electron withdrawing group, it will decreases the activity. And regarding the methyl group, there must be presence of methyl group at the second and sixth position to show the better activity. Okay, so these are some examples which are given in your syllabus, which act as the calcium channel blocker under the 1,4 dihydropyridine derivative. So nifedipine असेल R1CH3, R2, R3 COOCH3. At X, nitro group is present. In case of amlodipine, CH2O, CH22, NH2 group is present. At R2 and R3 there are different groups, so they becomes the chiral center. And at the second position, chlorine group is present. In case of nimodipine, CH3, these two groups are present which are differ, so they having the chiral center. At the third position, nitro, that is the at the meta position. And in case of nicardipine, CH3 at R1, CH2, CH3 having the different groups, and at third position, that is at meta position, the nitro group is present. So in the exam they will ask 1 mark regarding the anti-periplanar and sim periplanar. So just note down this structure when I will provide the note, it will be there. Okay, so this is the structure. So at the third position there is a syn periplanar structure. This is the fifth position ester group. This is the anti periplanar. Okay, so what is the change? One is syn periplanar at third position. At the fifth position there is a anti periplanar structure. So if you gone through question paper, there is a must question for the 1 mark regarding this one. Okay, so this is about the calcium channel blocker, in which 1,4 dihydropyridine, and these are the examples of these drugs. These are some other calcium channel blocker. Okay, so benidipine, clinidipine, and ifosfamidipine. So these are some drugs which comes under the calcium channel blockers. So just go through the structures. Write down the structure in your notebook. Okay, so these are the calcium channel blockers: benidipine, clinidipine, and ifosfamidipine. So these are also the calcium channel blockers. These are also the calcium channel blockers which comes under the dihydropyridine. 1,4 dihydropyridine structure.